Let's keep talking about quality advocates, section 4. It's the last section we talked about in chapter 2. We are still with Dr. Deming. Dr. Deming summed up his knowledge towards the end of his life with Dr. Deming's theory of profound knowledge. He wrote about it in his final book, The New Economics. Those 4 theories of profound knowledge include an appreciation. Leadership has an appreciation for a system. They know about variation. They have theory of knowledge, and there's psychology involved with leadership. Let me talk about each one a little bit more. First one, an appreciation for a system. Effective leaders have an appreciation for the systems that work together to create the organization's products and services. They understand the interactions, the interrelationships, and flow of a complex system. Those who have an appreciation for a system create alignment between their customers' needs, requirements, and expectations, the systems that produce the products and services, and their organization's purpose. The second one, knowledge about variation. It means that leaders are able to distinguish between controlled and uncontrolled variation, or common cause and assignable cause variation. Remember, those were the terms defined by Dr. Short. They are, we always have either common cause or assignable cause variation in a process. Common causes variation is controlled variation. If you think you have too much common cause variation, the only way you can remove that is by fundamentally changing the process. Remember the red bead experiment that illustrated that? Number 3, the theory of knowledge involves using data to understand situations by being able to comprehend how people learn. Dr. Deming encouraged the use of fact-based information when making decisions. So what that means is that effective leaders gather and analyze information for trends, patterns, and anomalies before reaching conclusions. That's basically what this class is all about. And then number 4, psychology. An understanding of psychology enables us to understand each other better, whether as customers or employees. By understanding people, their interactions, and their intrinsic motivations, leaders can make better decisions. So much about Dr. Deming. Let's start talking about Dr. Juran. Dr. Juran kind of took the Pareto principle and applied it to quality. Now, in the next chapter we'll learn about Wilfredo Pareto, who invented the Pareto chart, which has to do with the 80-20 principle. Wilfredo Pareto in the 19th century figured out that 80% of the money in Italy was in the hands of only 20% of the people. And Juran figured that most of the quality problems were due to just a few things that go wrong. So if you figure out those vital few things, then you will have a great impact on improving quality and the ability to meet customers' needs. He also talked about the big Q versus the little q. He said that quality is a concept that's found in all aspects of the business. He said quality needs to be broadly applied. So if you, for example, look in your books on page 34 at the bottom in figure 2.11, you can see that quality doesn't just apply to the manufactured goods and the point of service. It applies to all products and services, whether for sale or not. Processes. You don't just focus on processes that directly relate to the manufacturing of goods. You focus on all processes to have a good quality product. You focus on the process that has to do with manufacturing, but also with the business aspects of, for example, you need to have a quality ordering of material process. You need to have a quality process of paying your bills, of invoicing the customer, and so on and so forth. So quality needs to be applied to all processes broadly, needs to be applied broadly. He had 3 universal processes for managing quality. First, he said quality planning means you have to understand what the customer needs, and you have to design all aspects of a system to meet those needs reliably. Then he said you need to apply quality control. That means constantly monitor the performance of your processes. That's where SPC comes in. And then he said you need to constantly work on quality improvement. There's 2 theories. Number 1, you constantly improve a little bit, and then you put projects in place to have breakthrough improvements. Next I want to talk about is Philip Crosby. He said that really quality is free. If you're lacking quality, that's when the cost of quality becomes costly. So really spending money to reduce waste or improve efficiency saves you money in the long run. He had 4 absolutes of quality. Quality is first conformance to requirements. Then quality means prevention of defects. His standard was have 0 defects, and the way you measure all of that is through the cost of quality. We already talked about that in the last section. He talked about 5 erroneous assumptions of quality, so assumptions that are not true. Some people think quality means goodness, luxury, or shininess. Quality is intangible and therefore not measurable. It's all false. Quality is tangible, it can be measurable. We're going to talk about key performance indicators in the next section, where we will learn how to measure quality, and so on and so forth. Your book discusses each one of those. Then comes Ishikawa. Dr. Ishikawa is famous for the cause and effect diagram, also called the fishbone diagram or Ishikawa diagram. It's used a lot in industry to help you brainstorm on causes of problems, where you put the quality problem on the right, and then you draw arrows towards the middle arrow, and then you start brainstorming what could cause those problems. Now, usually companies like to use the 6 M's to entitle the major 6 branches, like man, machine, method, and so on and so forth. He also said there's really 7 tools of quality that everybody should know about in a company, from the plant manager through the treasurer, the engineers, the operators, really anybody. Customer service people, schedulers, maintenance people, anybody. And he said those 7 tools of quality are the flow chart, the control chart, the check sheet, histogram, Pareto diagram, cause and effect diagram, and scatter diagram, and I wholeheartedly agree with him. You will learn most of those tools in the SPC class, and then if you keep going to the Six Sigma methodology class, you will learn them all. Dr. Ishikawa promoted the use of quality circles, where companies would form quality circles, little teams of 4 or 5 people that would meet on a regular basis every week and slowly but surely improve quality issues. He focused on 4 areas to influence quality. He talked about marketing quality, worker involvement, quality begins and ends with education, and selfless personal commitment. Your book talks a little more about all those concepts on page 35. Then came Taguchi. Taguchi was famous for bringing design of experiments into manufacturing. Those were at that time complicated statistical procedures, especially prior to the use of software. Everything had to be hand calculated. He also talked about the Taguchi loss function, where you can see that on the left you have a little figure where you can see the lower spec limit on the left and the upper spec limit on the right, kind of like goalposts. Then you can see if you produce within the goalpost you have no loss. If you produce outside the goalpost you do have a loss. And then on the right it's the same figure. We added the target and the loss function is a little smaller. The area within the goalpost that he outlined is a little smaller, indicating that if you have less variation, if not all your production eats up all the available space within the goalpost, your loss function is smaller. In a nutshell, it says if you can produce with less variation, so you don't need to eat up all your available specifications, you will have a better product, you will have lower cost of quality. The book talks about that on page 38. Remember the case we talked about where the American transmission manufacturer had higher warranty returns than the Japanese transmission manufacturer, and it all boiled down to how much variation they had. The United States company had more, actually twice as much variation as the Japanese manufacturer, and that directly translated into higher cost of quality. That kind of emphasizes the Taguchi loss function. The more variation you have, the more money you're going to lose.